Hey guys, got a video here today on making a carbon fibre octagonal moderator for my AGT Manul. So I found an octagonal section of carbon fibre on AliExpress and thought it would make an interesting project, so that's what we're making here today. When the mod is finished, it will look something like this, and will simply slip over a barrel adapter and be secured in place using an M4 grub screw. The first thing I'm making is the moderator adapter, which screws onto the barrel. The standard pistol comes fitted with an M14 by 1.25 adapter. However, because the moderator I am making is an unusual shape, I can't just use a threaded adapter. I need to align the mod with the sides of the pistol, so what I'm doing here is making a new one with a plain shank. It's a very simple piece that has a 6mm hole running through the middle, an M10 by 1 female thread in one end to screw onto the barrel, and a boss with an O-ring groove around the outside, which locates on the outer barrel shroud. On the other end, the adapter will have an 14mm diameter plain shank, which our moderator body will slide over. The adapter is made from steel and will be cold blued when it's finished, and that will just prevent it from rusting. What you have seen me do so far is rough out all the external features, drill through using a 6mm drill, then open that hole out to 9mm, 15mm deep for our M10 by 1 thread. Once it was drilled to size, I then tapped it, and with that done, I came back through and finished all the external features to size, put the O-ring groove in the boss whilst testing the fit against our barrel shroud, and once the fit was where I wanted it, I parted the piece off, flipped it around in the chuck, and turned the other side down to 14mm, finishing the part off by just chamfering the edges. Next up, we can start work on the moderator body and end cap. At this stage, both pieces are machined in pretty much the same way, so I'm only showing making one piece in each setup. Firstly, I turned a spigot on both pieces off camera so I could hold them in both the lathe and the mill nice and easily. With the parts held by the spigot, the first thing to do was turn the OD down to 32mm, and this was done to remove most of the waste material and ensure we have a good surface to reference in the following setups. With the OD work complete, the next thing I did was drill a 6mm hole all the way through the parts. This will be the hole that the pellet travels through, and to drill this I'm using a standard 5mm drill first to create a pilot hole. Then I can come through with a long 6mm drill and get the holes drilled to size and depth. Next, I have the moderator end cap in the mill. I will give you a good look at the setup shortly, but for now we're just milling the flats on the moderator to match the carbon fibre tube profile. I need the profile to measure 30mm tall and 20mm wide, and to do that I'm just rotating the piece in the spindexer, milling the sides down to size. With the outside measurements to size, the next thing to do was to mill down a spigot on the end to suit the internal dimensions of the carbon fibre profile, which is around 28.15mm by 18.1mm. This needs to be a tight fit, so I'm taking it down nice and slowly, checking the fit against the tube as I go. With the sides milled down to size, next I milled the corners off. These need to be milled at 45 degrees to the sides, milling the outside corners off first, then moving on to the inside ones. Again, these need to be about 1mm deep on each side and a tight fit within the carbon fibre tube profile. Once I was happy with the fit, the last thing to do to the end cap in this setup was to mill a decorative undercut on the front. This was done using a 10mm end mill, just coming in about 1mm at a time, taking cuts along the bottom. This was done for a little bit of weight reduction and to make the end a little more interesting. Right then, so before we go ahead and move back over to the lathe, I thought I'd give you a quick look at the setup I used to complete those milling operations. So we're obviously over at the mill. We have our spindexer held into our milling vise. And the spindexer just allows us to accurately rotate the part around a central axis. So if I loosen the two clamps there, you can see that the part spins nice and freely around a central axis. And then when we want to index it to a certain degree marker, we just look round this plate here and then line the plate up with this small V in the top when we reach the number that we want. So for 90 degrees, we just push the pin in there, and now the piece is locked in 90 degrees from 0. That's how I did the first operation, so it was 90 degrees, then 180, 270, and then back to 0 once again. To mill the 45s on the side here, it was pretty much the same thing, although we did have to move the pin from the 0 position up to the 5 position. So just like so, and then we can rotate round, line up our 4, go about halfway through, then push the pin into position. And that just locks the part in at 45 degrees from our 0. Now the part that I've been working on at the moment is the moderator core. The part that you saw me do on camera was the end cap, this piece here. Both parts are made in pretty much the exact same way. All we needed to do was mill the outside to suit our carbon fibre, then mill a spigot on the inside so that the carbon fibre is a nice tight fit around the part. So I'll just push that over. Right then, and there we have it. So there's the carbon fibre pushed over the core. The end cap itself will be cut off at this line here, and then at the back here we'll have about 2mm of aluminium showing, and then I will need to do some more work to this back core section. With that said, that's the mill work done for now. We will have to come back to the mill very shortly, but the next thing I need to do is remove both parts from their support material and start work on the core back section, the part which fits over our adapter. Moving back over to the lathe, the first thing I did was remove some material from the back of the end cap, and this was done using a micro boring bar, taking out as much material as possible without breaking through the sidewalls, and again, this was done just to save a little bit of weight. With the weight saving exercise complete, the next job was to remove both the end cap and the moderator core from their support material. The supports have served their purpose and further work will not need the supports, so I'm just parting the parts off. Moving over to the moderator core, the last lathe operation was to bore the back out to 14mm, and this was done to suit the adapter we made earlier. To get the core on center, I'm setting it up in my 4-jaw chuck, indicating on the hole I drilled earlier. This is a nice simple job, as I only need to tighten the highs and loosen the lows, and once I got fairly near indicating on the hole, I moved over to the milled flats and made a small adjustment to the part to make sure it was perfectly on center. The hole did wander ever so slightly, although I did expect this as it is a 6mm hole drilled about 80mm deep into some support material. So I used the hole to roughly indicate the part, then used the flats to dial everything in perfect. Once the part was running true, I faced the back off and started work on the bore, removing most of the waste material using a 12mm end mill, then boring it out to 14mm using my micro boring bar. As I went, I checked the measurement using my snap gauge, and once it was cut to size, I checked the fit against the adapter. The final thing to do was to chamfer the edge, then cut a small relief in the bore for the grub screw hole, and this will just stop any burr formed by the drilling and tapping operation of the grub screw hole from interfering with the fit against the adapter. With that done, the next job was to finish off the end cap, starting off by milling the face square, just holding the part in the mill and working across the face. The last thing to do was cut the compensator slots in the end. First, the end cap was set up in the milling vise on a stack of parallels, and then I used an edge finder to zero out on the part and find the position of the slots. With that done, the parallels were removed, and I pre-drilled the locations of the slots just using a 3mm drill. With that done, I plunged out most of the waste material using a long 3mm end mill, and I did this in 2 stages. So the first stage was to plunge down to 10mm deep, and then the second stage was to plunge all the way through the part. This was done just to minimize deflection of the end mill, and in total there will be 3 slots 4mm wide. And to make sure the slots have a nice finish on the walls, the slots were first milled out to 3.5mm, then I finished the walls out using a long 4mm end mill, taking very light passes across the walls. With that done, that was the moderator end cap pretty much complete, so the next job was to move over to the moderator core and get the baffle sections milled out. First job was to set the moderator core in the mill vise, just on a small stack of parallels. Then I could use an edge finder to zero out on the part, then use the DRO to just find the positions of the baffles. To get the baffle chambers milled out, the first thing I did was come through with a 7mm drill. Again, this was used to just remove most of the waste material from the baffle chambers. And once I had all the material pre-drilled, I came through with an 8mm end mill, finished out the slots, and then milled along the side walls just to give the walls a nice clean finish. The baffles themselves were left around 2mm thick, and we took out as much material as possible from the side walls just to keep the moderator nice and light. The very last job was to drill and tap an M4 hole in the back. To do this, first the hole position was set up using a center drill, then I came through with a 3.3mm drill bit, which is tap in size for M4, then the hole was tapped using a spiral point M4 tap. With that done, that's job complete. I'll take you over to the bench and I'll show you the components finished. Right then, before we get everything glued up, I thought I'd give you a quick look at the components. So this is the moderator core, or the baffle section. We have a hole in this end so we can slide the moderator over our small adapter, then we can get that locked in place via a grub screw in the bottom. To be honest with you, it's not the ideal way of attaching a moderator, but as we can't just screw the mod onto the end of the pistol, this was the easiest and quickest way I could think to attach it without having to come up with some complicated solution. To go on the end of the mod, we also do have this little compensator section, so that's just that piece there. This is only a sub 6 foot-pound pistol, so the compensator pretty much does do nothing, but it does look quite cool on the end, so that's the reason I included it. We obviously have our octagonal piece of carbon fibre here, so I just cut that up off camera, squared up the ends, then put a small hole in the bottom so we could access the grub screw hole in the baffle. And then the last piece of the puzzle is the small adapter piece on the end there. So since the last time you saw this, I have drilled 4 holes around this section here, and then put a small hole in the end, just so I can use an Allen key to get this tightened up onto the barrel. I did also go ahead and cold blue it. Cold bluing never comes out as good as hot bluing, but it does stop the component from going rusty. I could have also made it out of stainless steel, it would have never gone rusty then, but as there are no other shiny parts on the rifle, I thought I'd keep everything nice and simple with just black and blue. So I'll just get everything put together loosely, then I'll get everything glued up and we'll take the pistol downrange and see how quiet it is. Right then, with that all said and done, I'd have one or two more things that I want to mention. So firstly, it is really quite difficult to capture the actual noise of the moderator on camera, as the camera microphone auto balances the volume so that you don't get any peaks or valleys in the volume. In person, the noise of the pellet hitting the backstop is usually a lot louder than the noise that comes out the end of the barrel, but I'll do my best to balance the audio levels so you get sort of a real-world example of how quiet it is. The only other things I want to mention is that it's nice and simple to put on the end, and with the moderator installed, it doesn't interfere with the iron sights. So as you can see there, the moderator is pretty much the same level as the barrel shroud section. I do run a Vortex CCW on the top of the mantle, but if I wanted to go back to the iron sights, the moderator would not get in the way. And the mod itself doesn't make filling the pistol any more difficult. But apart from that, that's pretty much going to do it for this particular video. So thank you very much for watching. I hope it's been interesting or useful, and I'll see you in the next one.